Now, what are we going to learn today? That's a $1,000,000 question. If we get the answer for this, you all will become millionaires. Yeah? Okay. So, who joined in between, I think Arihan joined and Vasundhara joined. Welcome you both. Okay. Abhiram, can you open the door for me? Coming. The one above. Okay, slow. Don't fall. Above one. Yes, thank you. Last week, come on in quickly. Okay. Find a place for yourself. Yeah. You can press that one. Yeah, thank you. Okay. So let's see what are we going to do today. Does anybody remember what did we do yesterday? I forgot. Constant of proportionality. I was just checking what you guys remember. I had not forgotten. Because I looked at yesterday's class and then I looked at what we want to do today. So I will not forget. I will keep on checking with you guys to see who remembers what we did yesterday. So we'll continue with that journey and we'll try learning a little bit more about understanding the proportional relationship. Then we'll talk about role, rate, ratio and proportion, and then we'll do some problems. Is that okay?
Yes, sir.
Okay. Myra, where are you right now? In the car or at home? At home. Come downstairs in the classroom. That gets waiting for you. Okay? Alright. So let's look at one problem as a jump start and then we'll go to the next concept. I have a question here that says the quantities of x and y are proportional. X and y are proportional. X and y are proportional and this is what is given to us. 15, 5, 25, 8, 1 by 3, 33, 11. And we have been told to find out the constant of proportionality in the equation y equal to Rx. Yadik, Arab, go ahead.
Y would equal, so y would equal 3 divided by x.
Okay, let's not kill the basic concept that I keep on insisting about, right? Nobody gets a prize for giving an answer in a hurry. Take your time, think about it, even if somebody answers after 2 minutes versus after 30 seconds, trust me, nothing goes wrong, okay? Take your time. I will appreciate you guys more for giving me a thoughtful answer rather than rushing for it. I am still not done reading this question itself. The question says the quantities x and y are proportional. And then we are given this table x and y. X is 15, y is 5. X is 25, y is 8, 1 by 3. X is 33, y is 11. And then it says find the constant of proportionality r. Find the constant of proportionality r in the equation y equal to Rx. So now I think I am done with where is the notebook? Take it out. You would need to get your hands dirty. Alright. Now I have told the question. Whoever has understood this by looking at this x and y being proportional, x and y values given, and this is y equal to Rx, R is the constant of proportionality. Find the value of R. Now tell me, Ara, what is the answer? R equals
1/5.
1/5. Okay, how about you, Advik?
Y equals x over 3 rating 1/3.
One more time, sir.
Y equals x over 3 rating 1/3.
So the question is simple. What is the value of constant of proportionality? Tell me what is the value of constant of proportionality, which is R. 1/3. That's what I wanted to hear. Okay, Shannon's Lane, tell me what.
We think it's 1/3.
1/3. Okay. See, now Shannon's Lane has become super smart. They are not saying I think, they're saying we think, because the answer coming from both of them. I'm just kidding. Okay.
Sir, could you see the question one more time? I wasn't here.
Yes. So the question says x and y are proportional. And then there is a table given to us. This is the value of x, this is the value of y. 15, 5, 25, 8, 1/3, 33, 11. And then says find out the constant of proportionality R in the equation y equal to R times x.
I got my answer, sir.
What is that?
I think it's 1/3.
1/3. Shaurya, Arihan.
Yeah, I got 1/3.
Everybody got 1/3. Anybody who got different answers, raise your hand. Okay, see, I silenced everybody in one statement. How about you, beta? 1/3. How about you? 1/3. Alright. 1/3. I want to see how. Okay. So this is not a big deal, okay? This is something that we have learned yesterday. And we were just doing the jump start with what we learned yesterday and just related. It says x and y are proportional. What does it mean? X and y have a relationship like this, meaning y over x will be equal to some value, or x over y will be equal to some value. When somebody says x and y are proportional, meaning every value of y over x will be the same value. Now we are coming to a point where we are relating ratio and proportionality. Now let's look at it. So what do you mean by ratio? People will say x over y, x ratio y, y ratio x, and you represent that as 1:2 or 2:1. And this is outside this question actually. So this is ratio. This is where you represent how they are faring against each other. When x is 1, y is 2. In this case, when y is 2, x is 1. This is what ratio means. Now, here if you see, when x is 15, y is 5. When x is 25, y is 8, 1/3. When x is 33, y is 11. So this is like a ratio, 50:5 or 25:8, 1/3. 33 is to 11. This is ratio. Now, when you say two numbers are proportional, or two variables are proportional, meaning each, when you do x over y, this value will be the same in all the scenarios. Since it says this is proportional, meaning 15 over 5 will be equal to 33 over 11, will be equal to 25 over 8, 1/3. If you want to check that, you can check it. 15 over 5 is how much? 3. 33 over 11, same 3. This over this, same 3. How? Is it super hard for you guys also like me, or it's okay?
It's hard.
Right? It's hot? It's hot? I'll get one more AC soon. If the temperature doesn't come down, I'll get one more AC. It will help me and you both. Alright. So here, 25 over this is also 1/3. Let's see. 25 over 8, 1/3. 8, 1/3. Can we convert this to a fraction as well? Using MAD? MAD, multiply, add, divide. 3 8 is 24 plus 125 over 3. So you can convert a mixed number into a improper fraction like this. So 25 over 25 over 3. 25 over 25 over 3. How do you convert it? It is as good as 25 divided by 25 over 3, correct? But you know what? I don't know how to divide. I only know how to multiply. So what I did, 25, I said, okay, convert this to multiplication. I converted this division to multiplication. Somebody got super angry and clicked upside down. Yeah. Now you can do tic-tac-toe. This value is also 3. 25 over this is also equal to 3. Yeah? Everybody knows math, right? Everybody knows math for converting a mixed number to a fraction. Yeah? If I say 82 by 3, convert this to a fraction. Multiply, then add, then divide. 8 3 is 24, plus 2 26, divide by 3. Yeah? That is math. Yeah? Okay? So, here, what I was trying to say was, in this case, when it says x and y are proportional, what it means is, every combination of x and y will give the same value. 15 over 5 will give the same value. 25 over this will give the same value. 33 over 3, 11 will give the same value. So when ratio of two variables are the same for each combination, then they are called proportional. Yeah. Now, why it is important? Yesterday we were talking about our plan for doing baking, right? We were talking about who all loves baking. And some of you said, we know how to do baking. Now let's say if we are only worried about in what proportion we use egg and flour for making cake. And somebody said, every egg, 2 cups of flour. If you are planning to make a small cake, 1 egg and 2 cups of flour is okay. If you are making a bigger cake and you got 2 eggs, then you need to have 2 into 2, 4 cups of flour. If you are making a little bigger cake and you want to use 8 eggs, you will use 2 into 8, that many cups of flour. Yeah? You are saying that make sure that you are using 8 egg and flour in the same proportion. If you mess it up, you put 8 eggs and 600 cups of flour. Cake will taste like flour. There will be no eggs flavor. If you put 60 eggs and 1 cup of flour, it will taste like omelette, not like a cake by any means. Yeah? That's why it is said it has to be the right proportion, meaning the ratio. Now you see, 1 is to 2, 0.5, 2 is to 4, 0.5, 8 is to 16, 0.5. The value is same. The proportion is same. The ratio gives you a form value that is matching. So that, see, ratio, rate and proportion will get confusing at times. But you have to understand that ratio is just a representation of one number against another one. 2 is to 3. This is ratio. You will not call this a rate. You will not call this a proportion also. When you talk about proportion, you will see 2, 3 combinations. And they will result into the same value. If you divide this by this by this, and this by this, you will get the same value. When the absolute value of that is the same, that's when it is called, it has same proportion, or the absolute value of the ratio being the same. Yep. Am I talking to myself? I mean, am I making sense to everybody? That's the question.
Yes, sir.
Okay. Sandrine, Celine, everybody, Tansi, Saurya. Where is Sanvita? Sanvita, okay? Okay.
Yeah.
Okay. All right. So now I will say, let me first give you guys a very basic definition or understanding of three things: ratio, rate, and proportion, and then we'll look at some more problems. Ratio. X and Y are in the ratio of 2:3. Just one value. Okay. My age to Tasvik's age has a ratio. Okay. 49 is to. This is the ratio of age between me and Tasvik. Okay. Now, if I say, this is just a comparison. If I say X by Y, meaning Tasvik's age versus my age, and if I get the absolute value 49 over 10, this is called rate. My age to Tasvik's rate is, my age to Tasvik's age has a rate of 4.9, meaning I am 4.9 times much older than Tasvik. My age is 4.9 times of Tasvik's age. This is the absolute value. So when you are looking at rate, you are looking at the absolute value. When you are looking at ratio, you are looking at a comparison. Okay? And proportion is something. Is it super hard for you? I mean, is it suffocating for you? Or it's okay? You were looking a little stressed out. That's what I'm asking. Okay? Yeah. Now, when comes the proportion into play? When you are comparing the ratio of X is to Y. X and Y's ratio. 1 is to 2. 2 is to 4. 3 is to 6. 4 is to 8. Think of this, the cake scenario that we talked about. When all the ratios are same for all the possible values of X, that is when you say they are in the same proportion. Meaning at every combination of the values for the variables X and Y, your absolute value is matching. That's when you say they are in the same proportion. Ratio is a comparison, rate is the absolute value, proportion is when you are comparing multiple ratios and you found them same, that's when you say they are in the same proportion. When do we use proportion? While baking, while making curries. Less amount of curry for one person. Same curry if you don't want to spoil the taste like I do. Ratio of spices versus the quantity. Constructing house, when you mix the cement with the other things for constructing the house, the concrete, if you mess up the proportion, the ratio between the ingredients, your house's wall will fall on your neighbor's wall. So, yeah? Everybody with me? So proportion gives you a scale to say, okay, if you want to do a small quantity, make sure that the combination is not getting messed up. Same thing, bigger quantity, don't mess up. And that's where you guys would be seeing the homemade food, very good, much tastier. Because what happens is, so if it's done in less quantity, the ratio is maintained. When you think about going to a much bigger restaurant where they are cooking for 200 people, they mess up the ingredients a little bit, or they did not cook it properly for long enough. They could not check each and every thing is getting cooked or not. This whole ratio got messed up. Proportion got skewed, and impact is quality of food. Same thing. So this is how you look at proportion as your scale for larger quantities, rate as for getting absolute value, and ratio as a relationship between two things. So far, everybody with me? Nihan? Arihan? Sandin, Sulain, Thansi, everybody? Okay. Let's move on to the next problem. Since we have talked about ratio and rate in between, at least we will not have any doubt coming across. Any doubt that will come across. Let's look at the next problem. The next problem is the quantities x and y are proportional. And this is a repeat of the previous problem probably, okay? X and y are proportional. And this should be done in less than 2 minutes, okay? If I have done a good job as a teacher. X and y values are given. 14, 1.4, 16, 1.6, 21, 2.1. Find the constant of proportionality R in the equation y equal to Rx. Constant of proportionality R in this equation, find out the constant of proportionality R in this equation.
Sir,
Yep.
my answer is 1/10.
1/10.
Yeah.
Okay. How about Arihan? I'm sorry?
Yeah, I know 1/10.
Okay. Is there anybody in the class who got anything different from 1/10? Raise your hand. Anybody who got anything different from 1/10? Tansi, go ahead.
Oh, sorry, I forgot to lower it. I got 1/10.
Okay, see, I am learning tricks to do it faster. Okay, anybody in the class who got anything different from 1/10? Same? Same? Tasvik? Same? Sure? 100%? Any question? Okay, see one thing here. I know sometimes you might think differently and you might get a different answer, but in such a scenario, y over, see here, y equal to Rx, y over x will be equal to R. This is what you have to find out. Put the, pick any value of y and pick the same corresponding value of x and see what the value is. Y over x, my bad. That's what I was thinking, how I'm getting 10 times more than you guys. Pick any combination of x and y, put it here, and that will be your value. Since you are told that they are proportional, you don't have to calculate for everybody. Okay? Just pick any combination and it should be fine. So we have muddled the water enough with this problem or this topic. Let's move on. Let's go to something different. Now we will look at a different problem. We can calculate the depth of a snow, depth d of snow in centimeters that accumulates in Harper's yard. Let me first clean it up, then we'll. So I am moving on to a different topic related to this, but different type of problems. Okay, you don't have to calculate the constant of proportionality this time. It says, the question says, we can calculate the depth d of snow. Depth d, okay? So d is the depth of snow. We can calculate the depth d of snow in centimeters that accumulates in Harper's yard during the first h hours of snowstorm. Using the equation d equals 5h. Again, I am reading the first two sentences. We can calculate the depth of snow, depth d of snow in centimeters that accumulates in Harper's yard during the first H hours of snowstorm using the equation D equals 5H. How many hours does it take for 1 centimeter? How many hours does it take for 1 centimeter of snow to accumulate in Harper's yard? How many hours it take for 1 centimeter of snow to accumulate in Harper's yard? And second question is, how many centimeters of snow accumulate in 1 hour? Sorry, how many centimeters of snow accumulate in 3 hours? Did everybody hear the question okay? Okay. I'm reading it one last time for myself. And let's see. We can calculate the depth D of snow in centimeters that accumulates in Harper's yard during the first H hours of snow using the equation D equals 5H. And then we are given two questions. One is, how many hours does it take for 1 centimeter of snow to accumulate in Harper's yard? And how many centimeters of snow accumulates in 3 hours? Now, let's see who all has answered. Yes, Aram.
For the first, answer will be 1 hour or 20 minutes. And then the second one.
Go slow. My ears are not that effective. Slow.
So the first one is 1 for an hour or 20 minutes.
1/5 of an hour
Or 20 minutes.
or 20 minutes.
Or 20.
Say it again. 20 minutes
Yeah.
or 1/5 of an hour. Okay. How about the second one?
The second one will be 15 inches will be I think that's about 3 hours.
50 inches. You have to tell in centimeters. How many centimeters of snow will accumulate in 3 hours?
15 centimeters about that.
Okay, 15 centimeters. Okay. Let's see what Sandin Celine has to say. Have to say.
We both got the same answer.
Same answer as Araf.
Yes.
So that means to accumulate 1 centimeter of snow, it will take 20 minutes or 1/5 of an hour. Is that what you guys are saying?
Yeah.
And in 3 hours, it will accumulate 15 centimeters of snow. I'm just confirming, okay? I'm not.
Yes.
Okay. Now, for the kids who have given the answer already, while I'm asking others to give the answer, make sure that you are reviewing your answer one more time. Get into that habit, okay? Whenever you save time by doing things quickly, use that wait time to review your answer, okay? I'll tell you why I'm saying so.
First one is 20 minutes.
Okay?
Second one is 9 centimeters.
How much?
9.
9 centimeters, okay? 29,
Seconds.
same answer. Myra,
20 minutes. 9 centimeters.
20 minutes and 9 centimeters. Okay, Samvita,
I got 20 minutes and 15 centimeters.
20 minutes and 15 centimeters. Okay, Shaurya, same. Okay, Advik, same. Arihan, same. Nihan, tell me. My mic not work. Okay, type it. Okay, now You guys will not like what I'm going to say now. Okay? 2 by 10 what? 2 by 10 minutes or hours? Yes, Anvita.
Never mind. It
Okay.
wasn't happening.
Okay. Now, whatever I will say, you guys will not like, because this is called a lamb effect. One lamb goes in the wrong direction, everybody follows him. Yes.
You said 1/5 of an hour to 12 minutes.
Exactly. That's what I was trying to come to. 1/5 of an hour is not 20 minutes. Everybody was rushing for saying same answer. And now you guys will appreciate why I say don't trust anybody when it comes to solving math. Do you guys see merit in what I'm saying? Tell me, when was 1/5 of an hour 20 minutes? 1 hour has 60 minutes. 1/5 of an hour. So, message is very clear. At least you guys will not disregard my statements going forward. Yes.
Is it 12 minutes?
So, see, everything that I say in the class, okay? Don't come to my classes the day you realize that I'm not being serious to what I'm doing. My focus is 100% in the class when I'm in the class. So every sentence, every word I say, barring my dad jokes, okay, has a reason for it. I mean, dad jokes also have a reason. It is just to keep you guys engaged, okay? Don't get stressed out. I say, don't trust your friends. Simple message is, you do your calculation. Don't get biased. Okay? Second thing, just 5 minutes ago I said, whoever has finished their question quickly, make sure that you are using a wait time to review your answers. I was hoping that somebody who has answered it quickly will review this and realize this mistake. Nobody listened to me. I know I'm too old to be listened, but please make sure that you build that in your practice, in your habit also. Okay? Because nobody is bad at math, okay? But everybody will get different score in the exam. And that will be a function of how much attention you are paying to what you are doing. That's why I keep irritating you guys by talking about RAM. Read the question again, analyze it and then do it. What happens? When I have not even finished my question, I see 2 hands being raised. That raises a red flag for me. For me, each one of you have to get near perfect score in your SAT exam. That's the goal I'm working on. And how would that happen? This in your habit, in your routine, in your behavior. Don't rush. Trust me, there's no prize for finishing all the questions 30 minutes before the exam gets over and 5 questions being wrong. You want to use the entire time, go all the way till last minute of the exam, and out of 5 being wrong, minimize that to 2 being wrong or 1 being wrong. Your score improves. Yeah? That's why I said, you guys will not like what I'll say, but trust me. I'm 100% with you guys here, and everything that I'm saying is a reason for it. So just have a little bit of respect for your teacher. Listen to my statements. You will see some merit in what I say. Okay? Is that okay, everybody? That was too big a lecture for that smaller problem, but it was not a lecture actually. I was just trying to get you guys aligned to certain ways of doing things. Okay? Now let's move on to the next problem. Is that okay? Or everybody got emotionally loaded after hearing my statement? Loaded? Nobody is loaded, right? Don't get loaded. Okay, let's look at One more problem and then I'll let you guys go. I have a very simple question, okay? It's more like a, what you call, a refresher for you guys. Bao is mixing flour and water to make dough. Bao is mixing water and flour to make a dough. Make dough. The graph shows how much water he uses for different amounts of flour. This graph, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is flour in liters and this is water in liters. How many liters of water does Bao use per liter of flour? One last time, I'm reading the question one more time for you. Bao, who is my childhood friend, is mixing flour and water to make dough. The graph shows how much water he uses for different amounts of water. How much flour, how much water he uses for different amount of flour. Based on this graph, tell me how many liters of water, does Bao use per liter of flour? Yep.
I got 0.3 liters
Okay.
per liter of flour.
Okay. How about Arihan?
Wait, can you repeat the question? The laptop,
Okay. Bao is mixing flour and water to make dough. The graph shows how much water he uses for different amounts of flour. Here you have flour, 1, 2, 3. Here you have water, 1, 2, 3, 4, 5. So as per the graph, the question is, how many liters of water does Bao use per liter of flour? Did you hear the question you had this time?
Yeah.
Okay.
Wait, what was that end part? Per flour?
Say that again.
What was the end part? He said thou per flour.
So there is no information given. Says he mixes water and flour to make dough, and this graph shows how much water and how much flour he is using. So based on this graph, you have to find out how many liters of water does Bao use per liter of flour. 1.5. Okay. 1. Okay. Let's see what Arvind has to say.
1/3.
1/3. Okay. Okay. Sanvita.
1/3.
Shaurya.
Right now I don't know.
Okay. Gayatri.
I wrote 1/3.
1/3. Gitesh.
I got 1/3.
Anybody who did not get 1/3. And again, I'm not saying 1/3 is right. Raise your hand if you got anything different from 1/3. Otherwise, your hands down. Okay, so everybody else got 1/3. Again, I'm not saying that 1/3 is the answer. Okay, trust me.
I got
1.5. Okay, so I got 1.5 from you, 1 from you. Everybody else has given me 1/3. Yes, Arihan.
That was
Okay, but is your answer also 1/3?
Yeah.
I have 3 varieties of answer and I don't know which one is correct, okay, because I've not done my job. 1, half and 1/3. Let's look at it. It says bowl uses water and flour for making dough. And I don't know which one is correct. I mean, that's the only information we have. And then we are given this graph and we have been told to find out how many liters of flour he uses for every liter of water. Now look at this graph. He uses 3 liters of flour for 1 liter of water. Again, let me read the question again. It says, how many liters of water does Bao use per liter of flour? So he uses 1 liter of water for 3 liters of flour. So 3 liters of flour, he uses 1 liter of water. For 1 liter of flour, how much he will use? This comes down, a butterfly, 1/3. With me? Make sense? Yeah. So again, no answer is wrong. I must give you guys credit for telling me the answer because at least that gives me a clue into how you are approaching the problem. So if you want to tell me, Abraham, what was the difference between the way we were thinking or you thought?
I thought 3 was a little bit above 1.
Okay. Maybe that would have been the reason, yeah. And again, that it's courtesy my drawing skills. I did not draw it properly, but still I did not do that bad a job.
It's not that bad, but it was a close
Close,
one.
yeah.
So
Okay. You probably assumed it's probably 1.5. That's what led to that. What was your thought process? And again, I'm not putting you on the spot. I'm just trying to get your thinking behind. You thought a little differently. But is it clear now? It's clear? Okay. So that was the next problem that we had. So what did we do today? We looked at the difference between ratio, rate and proportion. And we found that if the ratio is same for multiple combination, that's when we say proportion is same. And that's what we use for our day-to-day living, making cakes, making houses, making curries, making dal, chapati. See, Mao was also making chapati using rice and flour and water, right? So this is the concept, and we'll touch upon one more thing about this in the next class, and then we'll go to our next topic. That is about derived units. Okay, rate is nothing but absolute value. When you compare two numbers and you translate that to exact value, 3/5, it translates into 0.6. That is what is called rate. But then, in case of rate, you always don't use the same unit. You use different units. 5 miles per hour. I eat 8 chapatis per day. This is rate. When your numerator and denominator have different units, those are called derived units. Okay? 5 chapters per hour. Chapters is a different unit. Hour is time. When you use different units and use that for deriving or describing something, that is called rate. You'll say, okay, what is the rate at which your car is running? 70 miles per hour. Mile is distance, hour is time. You're talking about two different units. But then you're combining them together to talk about speed. These are called derived units. So we'll talk about that a little bit and then we'll move on to the next topic in the coming class. Alright? With that being said, enjoy the rest of your evening, have fun. We'll talk again next week. Yeah, that is the interesting part of life.
Hi, sir. Thank you.
Alright, bye bye.